All right, let's get starting with 1-2, Chapter 1, Section 2, Algebraic Expressions. So let's look at our first objective, evaluating algebraic expressions. So a couple new vocab phrases for us. And the first one we've got here is a variable. So a variable is a symbol, usually a letter, and we've used these a whole bunch, X, Y, Z. We remember these. That represents one or more numbers. So variable, letter that stands for a number. And remember, it's a number we don't know. So variable represents an unknown number. Something that we don't know. All right, and anytime that you have an expression that has one or more variables in it, it's an algebraic expression or a variable expression. So the algebraic expression and variable expression mean the exact same thing. All right, it's just an expression with a variable in it. So anything like 5x or 5x plus 3 or 9y or z cubed, those are all algebraic expressions. Notice that they're not equations. What do you need to have an equation? You need an equal sign. So once you have an equal sign, then it's an equation. But without the equal sign, it's an expression. All right? So that's what we're looking for. These are all expressions. And then when you substitute numbers in and you figure out what the numbers are for your variables, then you are evaluating the expression. So if we said 5x plus 3, and we know that x equals 2, then we're going to evaluate this and say, oh, instead of x, now we know that x is 2. And we plug it in, and we can figure it out from there. So that's evaluating the expression, is when you plug in numbers for your variables. All right, so let's try this a couple times. Our first one here, let's evaluate. So we're going to plug in numbers for our variables here. So a minus 2b plus ab. If a is 3, let's start with that. Everywhere I see a, I see a here and here, I'm going to write down 3 instead. So minus 2 plus 3b. And instead of b, I'm going to plug in negative 1. So 3 minus 2. I'm going to put it in parentheses just to keep it protected and know we're multiplying here. And now we're going to evaluate following the order of operations and clean it up. So first we're going to multiply. 2 times negative 1 is, negative 2 times negative 1 is positive 2. And 3 times negative 1 is minus 3. And so now order of operations, we'll go left to right. First we'll say 3 plus 2. And then we'll subtract and get 2. So our answer is 2. All right, you're up on your worksheet. Try the first understanding check. All right, let's try this again. Example 2, and we're going to evaluate again. We're going to plug in 3 for x this time. It's telling us right here what x is. So negative, instead of x, I'm going to put parentheses and put a 3 in there. Everything else stays exactly the same. Everywhere I see an x, I put in a 3. All right, order of operations first. We're going to do parentheses. So the parentheses that needs cleaning up is right here. 3 plus 1 is 4. Then we need to do exponents. And here's a little bit tricky. This negative right here is not part of this exponent. The exponent is only going to the parentheses. So it's 3 squared, that's 9. This negative is still out front of it. All right? The squared only went to the 3, not the negative in front of it. Minus, what's 2 times 4? 8. And negative 9 minus 8 is negative 17. All right? So be very careful with when you're squaring or using any sort of exponent and you have the negative numbers and parentheses. The negative has to be inside the parentheses to belong to the exponent. All right, you're up. Try the understanding check problem for example 2. All right, example 3. Let's take a look at a real-world connection here. Elections. So we have an expression, negative 0.3y plus 61 is a model for the percent of eligible voters who voted in presidential elections from 1960 to 2000. In the expression, y is the number of years since 1960. Find the approximate percentage of voters who voted in 1988. All right, so here's our expression. Negative 0.3y plus 61. All right, and they said y is the year since 1960. So if we were in 1961, y would equal 1, right? But we're in 1988. So let's figure out how many years that's been since 1960. So to figure that out, we're going to subtract 8. 8 minus 6 is 2, and the rest cancels out. So in this case, y equals 28. So we're going to go ahead and plug this in. They say plug in 28 for y plus 61. All right, and so we're going to go ahead and figure out what is 0.3 times 28. Let's do some multiplying here. 28 times, I'm just going to put 3 right here and not worry about the decimal to start. 8 times 3 is 24. 2 times 3 is 6, plus 2 is 8. All right, so we've got 84 down here. And now we need to figure out, all right, where is the decimal going to end up? And in this case, 0.3 is smaller than 28 by 1 decimal. Sorry about that, got distracted, somebody came into the room. So like we were saying, we've got 1 decimal place, so we're going to move our answer decimal over by 1, so 8.4, negative 8.4 plus 61. And let's add those things up together. This is really 61 minus 8.4. 61 minus 8 is 53. Take away 0.4 is 52.6. And that would be our answer. All right? So you're going to use this information and this model for the understanding check, which go ahead and try that right now. All right, moving on into Objective 2, we're going to simplify algebraic expressions, and a couple more things we need in here, terms and coefficients. All right, so terms are the parts of each expression. All right, so if I've got 5x squared plus 2x plus 7, I have 3 terms. The first one, the second one, and the third one. And the coefficients here, the coefficients are the numbers in front of the terms, all right? Numbers in front of variables are the coefficients. So in this case, the coefficient would be 5. In this case, the coefficient would be 2, all right? 7 is not a coefficient because there's no x in front of it. There's no variables, so no coefficient on that one. All right, and then the phrase here, like terms, if we have the same power, dealing with the same exponent, we are like terms. So in this example here, there aren't any like terms. But if we did this, 5x plus 7x, these are both like terms because both of the exponents are the same. They'd be the first power. All right, so terms, coefficients, and like terms. Let's take a look at a couple properties here. Subtraction. We learned this yesterday, or last class, that subtraction is really just the same as adding negative numbers. Division is the same as multiplying the reciprocal, right? So this is for fractions. If we don't like fractions, we can always flip it over and multiply instead of dividing a fraction, okay? Distributive property for subtraction, right? The a is going to distribute in there, so distributing in here. And if I'm going too fast, feel free to pause this so you can fill in your worksheet. Multiplying, if we ever multiply anything by 0, what do we get? We get 0, so anything times 0 is 0. If we multiply by -1, we're just going to change our sign. So -1 times a, we make it negative a. Opposite of a sum, so the opposite of a plus b is negative a and negative b. All right, so you can distribute the negative. This is a really common mistake. We forget to remember there's really a 1 right in here, so we're going to distribute -1 into both numbers. How about for a difference? We're still distributing -1 in here, so we'd have negative a, but what's a negative times a negative? That's going to turn into a positive for b. All right, so remember to put a little 1 there and distribute it in. If we put opposite of a product, remember product's multiplying, right? only one of them ends up negative if we wanted to pull them out. Okay, because remember, a negative times a positive turns back into a negative. And last one, opposite of an opposite. Two wrongs make a right in this case. Negative and a negative turn into a positive. All right, so this should be a review from algebra, but we need to bring this back. Haven't seen it in a while maybe. And so let's go ahead and use these. Let's simplify by combining some like terms. So we can just combine these. 3k minus k. What's in front of this k? There's a 1 right there. So since they're like terms, a k with a k, we're going to go 3 minus 1 and get 2, and we keep the k in front of it. Okay, how about the next one here? Oops, let me erase that. Oh, you're not erasing. Hold on. There we go. All right, so let's look at our like terms here. So in this case, z squared and z squared are what I see. So 5, negative 8. 5 minus 8 is negative 3, and we keep the variable z squared. And then z and z, it's a negative 10 and a positive 1, so that's negative 9. Try one more. All right, we got to distribute first. So this is negative m. Remember, a negative times a negative is a positive, plus, we're going to distribute again, 2m. 2 times negative 3 is minus 6. n, let's put these together. What are our like terms? m and m. Negative m plus 2 is positive 1. And then we got to go with our n's. We've got 1 minus 6, so that's minus 5n. And that's what we should end up with. Okay, there's a couple for you to try here. Try those. That's the fire alarm. We'll come back to this. Okay, we are back from the fire drill. Everybody's safe and sound. I apologize for that. Hopefully it didn't freak you out too much with the loud noise there on the video. Alright, so try example 4. Hopefully you've tried that. Let's move on to example 5. Alright, so let's remember what perimeter means. Perimeter means we're going to add up all the sides. So we're going to start down here. So 2a. I'm just going to start writing them down. 2a. And I'm going to go clockwise, everything I see. So the next one I see is an A. I cross them off as I see them. Then I see A plus, oh boy, 2A minus B over 2. Got that one. Plus, and let me just get them all right here. 1, 2, I'm going to combine them as we go. Plus 3B's plus 2A minus B over 2 plus another A. All right, so let's combine our like terms here. So the first thing I see is A's. Let's get those. I see 2. 1 more is 3. 1 more is 4. So there's 4A. And let's just get this plus 3B taken care of over here. And then we've got this big fraction here. So we've got this one plus this one. We need to put it together. So when we're dealing with fractions, let's remember when we add the numerators, keep the denominators the same. So I've got 2a and 2a, that's going to be 4a minus 1b minus another b, that's minus 2b all over 2. And we got to simplify one more step. We can divide here. So it's 4a plus 3b, those are just normal, plus, what's 4 divided by 2? Should get 2a. Minus, what's 2 divided by 2? 1b. All right, so now we can combine one last step. 4a and 2a is 6a. 3 minus 1 is positive 2b. And that's your answer. So you need to do something very similar for your checkpoint problem, and go ahead and give that a shot. And that's it for 1-2. Questions, make sure to ask me in class.